Yeah, you can start.
Yeah. Once the screen is visible, please let me know.
Yes, it's visible.
Okay. Yes. Yes. Hello, friends. Uh, this good afternoon. This is regarding the autonomous vehicles. Introduction. Slight introduction. How the vehicle is working, which all component is used inside a vehicle, so that we can get the data on the cloud, as we can manipulate the data inside a vehicle. For that component, I am going to describe the systems. So once you are seeing your vehicle, uh, nowadays that the okay, any automatic vehicles you have seen it. So in that you are just you have that a center
We
locking
can
system
manage.
is there. Central locking means central lock door is there. Central window locking is there also there. So in that case that you what you can do that you are seeing that already that some of the component is is contacting to each other to manipulate the data inside a car. So that what all component is there inside of the vehicles that I'm explaining you. First, we can see that the ECU. It is actually electronic component unit. So what does it do? That electronic component unit is a small set of the microcontroller. You can say that microcontroller is controlled by the embedded software. Means here what we are doing it that the software we have to write it, and that software we have to write, and then we have to embed on the chip. So it is mostly what does it do that the controls that one of the several part of the vehicles. So here once you are doing that the locking of the lock lock of the door, central locking. So central locking is that, so it is some communication is happening between the one component to another component. That way it is controlled at one of the several part of the vehicles. So in that case, how it is working the ECU? So here first it is taking the input, and then whatever input is coming that. So on the basis of the input, it is processing the data, and then it is giving the output. So input, what we can think about it? Input is basically we can think about the everywhere the uh, component we can think about it. It is a sensor is implemented there. Okay, and that sensor sends the data, and that sensor is basically we can think about the physical uh, physical or chemical um, device of the system. Okay, and that is that is basically that is that is basically that the sensor sends the signal to the processor. This processor is actually electronic compute unit is there, and then the what is the output? Output is done by the actuator. It is the actuator. So on the basis of the information, what what the actuator got is the informations. So that information can be relayed to the different parts of the vehicles. So that way it it acts it. So once you are sending the signal from sensor to the ECU part or processor part, it is basically that the analog to digital conversion is happening. So ECU only listens at the digital conversion, digital data, and once this digital data is is passed to the actuator, so it is actually it is happening to digital to analog conversion. So what I can say that so this input to process and the output the physical device conversion to it is physical signal, it is converting to physical signal to electrical signal, and after electrical signal it is converting to mechanical signal. So And this ECU device connected with the several parts of the vehicles and tells what to do and how to operate on the basis of the command given to it. And why ECU has been used at the, because we have to find a problem inside the vehicles. What all issues between the different parts of the mechanical parts or different parts of the electrical parts is happening that we can see on the dashboard, and we can find that okay, this is the issue is coming and how can we resolve quickly. That's where the issue has been used mostly. So anything? Any questions here?
What does this stands for, ECU?
ECU is actually electronic compute unit.
Okay. Madhu, this is Sivam. There are a couple of questions I have. One is, you told a command or the input has to provide. It can be any kind of commands, voice commands, or how the input is provided. Because you told sensor, no? It can be a audio, voice recognition sensor, touch sensor. What kind of sensors and what kind of commands are there? Second part of my question is, how the issues are identified? Is issues are identified automatically by the ECU, or there must be a human or manual intervention? Okay. To tell the ECU the issue is happening, please address that. These are my couple of questions.
Okay. See, what I told that first it is taking the input and then it is converting the output. That input is coming from the vehicles. So we are not giving that any command from our side right now. So what is happening that this suppose that the brake system is there. Brake system having the brake pedals is there. Then we can yeah, you want to tell something?
No. Go ahead, Madhu.
Okay.
I'm just following you. Okay.
Okay. So brake pedals, brake. So here you want to put the brake, yes, on the vehicles. So what is happening that once you are putting the brake on the vehicles, so there are the multiple components are involved inside the vehicle. One is the brake pedal will be there. Inside the then there is a some component inside the inside the wheel, and then some lighting should be there. So here we are just sending the signal that okay, what we have to do it, okay, through that machine coding, and that machine coding, that software is already defined onto the chip system.
Okay.
Okay, so we are not sending any voice command here. We are just first I am explaining about the ECU part data. Then I will come to the TCU. Then you will understand how the TCU conversion is happening to the ECU conversion. So
okay.
this is I am telling about the ECU part.
Okay, got it.
So here any questions?
No, Madhu, you go ahead.
Okay. Anyone want to add something? Okay. Now we can see that the ECU board. So what all board consists of, that we can see that. So here once we are seeing that the microcontroller, CPU and the memory, we can see it. And inside of the CPU or memory that we can put our software inside it. That software can be combination of the any microservices. Okay, we can write any microservices microservice applications here. Okay, and then here's a CAN port is there and a CAN controller, and the FlexRay port is there. This is for the networking system inside of the vehicle, how the networking communication is happening between the vehicles, within the component of the vehicles. That is used for the CAN controller, CAN port and FlexRay port. Okay. And
okay. Yeah.
And here you can see that the downside there is a actually button is there, the chips is there. So here chips, you can see that you can get the output also from the system, from the vehicle system. Okay. Now, what is the use of the ECU then? Okay. So once you are seeing the, okay, I'm coming to the last one, and then I'll come to this one. So here you can see that the body part of the car. Once you are seeing the body part of the car, so here are the multiple body part of the system is involved here. Okay. So here you can see that the multiple control system is there. Okay. That control system, that so this control system can be source of the input of the ECU. Okay. That, and so it is a different use case of the ECU. We can define it. That I am coming at the, yeah. This is the body control module is there. Body control module is that, okay. So here once you are seeing at the outside of the car, like closing the door, or yes, opening a door, or switch on the light, okay, or sunroof, switch on the sunroof of the car. That way the body control module has been used. Then a climate control modules. Climate control models, here what way it works at the, okay, what is the right now, what is the temperature of the system, what is the temperature of the temperature of the outside, or what is the temperature of the inside, and in that case the how the what should be the actual temperature of the AC. It should be on. It should be, what should be the optimum level of the EC should be there. So that way the climate control module works. Third is the electronic brake control models. We have the ABS system. We have ABS in the system. That ABS, how it should be worked inside of the app, inside a vehicle, or in that case how the auto brake system should work. That way the electronic brake control module is working. We have the lots of things are there. I have not gone to. Yes, I know that the most of the thing, but in the deeply I did not get a chance to work. I get a chance to work on the telematic control unit and the ECU part I got to work. But if anybody wants to ask a question related to these types of the ECU, please let me know so that I will explain it.
Madhup, what is body control modules? What kind of controls are there?
Which one?
Body control modules.
Okay, body control modules is like, yeah. See here body control mod. Okay, I will explain. See, body control modules. You can see that the here what I can see that the closing of the gate, or closing of the window, closing of the sunroof. Okay, this all things will come inside a body control module. Body control module consists of the system which is applicable on the body of the car. Okay.
Sure, got it.
And the body controls module is there. Okay, here. Sorry, I have had. So body control module is there. The lighting control is there. Wiper control is there. Power window is there. Okay, rapid light control is there. Door lock, sitting control. These all are coming inside body control modules. Okay.
Okay.
Now climate control modules there. So inside this we have the sun sensor, AQS sensor, control head is there, motor actuator is there, humidity sensor is there. So these are all coming inside the climate control modules. This climate control modules is used for what will be the optimum temperature inside the car. So it will take the data from the sensor, and then what it will do that it will process the data, and then accordingly the output it will be defined by the actuator. So here battery management is also there. So battery management nowadays that the electrical vehicle system is coming. So in that case that we know that we know that how much it requires a charging. So everywhere it, it, it is defined at the so inside the battery management it is defined at how much battery is remaining, and in that case how much power is getting turned. So in that case, how much power is putting inside of the vehicles. Okay, so that way it is measures between the required and what is the input is coming from from the from the from the charger. That way it works. Okay, this is the advanced driver assistance system. So in that case, the advanced driver assistance system, how it works that once I explain at the TCU part that then we'll come to this page again. Okay. Okay. Now that we have lots of the ECU. So once you see that the ECU component inside of the vehicle, we can say that the more than 70 to 100 ECU part will be there. And then communication between the one ECU to different ECU, it will take lots of time if it is combined with the one network connectivities. So what happened at the vehicle has been defined. Vehicle has been segregated by different network architectures. Okay, different blocks, and that blocks is defined by the different ECU main component. So here we can see that first we can see that we have the safety time and critical data. What is more safety things we required? See, once we are driving the car, and once we are putting the brake on the car, that brake should be applied very fastly, and it should indicate that behind also that car is getting stopped, so you should be stopped. Similarly, we have the steering control should be there on the car. So that is a safety time critical data we can think about it, and it is segregated with the safety time critical data. Now we have the infotainment network. Infotainment networks like that. We want to play something on the dashboard of the car, or radio we want to listen it. So that will come under the infotainment network. Now we require door lock. Door lock is also safety concern, but it is not the immediate safety concern. Door lock is required, but it can be it can be solved by the low cost or speed data. Now we have the engine transmission alternator. This all is the control data. That control data can be controlled by the most of the part of the sensor and the actuator. And we require here the higher bandwidth of the data also required. And here's the backbone. Backbone communicates between the one part of the one component of the vehicles to the other component of the vehicle. Now we have the multi-giga data. Multi-giga data, what does it do? That we require that actually everywhere you can see that nowadays the ADAS system is coming, and it is required a dedicated streaming of the video everywhere. So for that purpose, we require a high bandwidth of the network so that it can process the data very fast, and it can give the output of the data very fast. So we can think about it This is the autonomous ECU. It is, we can think about, okay, we require a high bandwidth of the data is unidirection, one direction, but that directions so that we can get lots of data here and we can process the data, and then this process of data can be communicated through the backbone between the different channel wherever it is required. So that way this is the autonomous ECU it is the new concepts is coming. So any questions here?
Before autonomous ECO, what was used for processing the visual data?
Okay, before the autonomous ECU, so right now we have lots of vehicles having the high resolution camera is there. Okay, but before that we don't have the high resolution camera in front. Okay, so it is a new concept is coming there, and before that we don't have the camera inside a car. Right?
Okay.
Okay. Now we can go ahead with the, okay, why this network, how it can be segregated. Okay. So inside a vehicle, I will explain about the, okay, what is important and what is a low priority. Okay. So once we see that the high priority thing, so high priority gateway has been connected by the CAN network. CAN network has been called as a control area network. Okay, and they having a different set of the header is there inside it for every information to process. Then we have the LIN is there. LIN is local interconnectivity network is there. Okay, and once you see that okay, this why it has been segregated between the different CAN, LIN, flex tray and Ethernet. So you can see that, okay, so in that case how the control flow is happening in last phase. So that way it has been segregated. And here is actually Ethernet is there. Okay, so Ethernet, and then it is a flex tray is there. This is the different type of the networks inside of the vehicles, and this network has been defined by the AutoSAR. See, actually earlier what was happening that every vehicles or every OEM having their own hardware, and then on the top of the hardware they are making a software. But right now the AutoSAR is coming with a specification, and that specification has to followed by each OEM. So that way that they have defined this all network should be segregated. They can write a software according to their need, but actually hardware and the specification should be defined by the AutoSAR. Okay. Okay, in what case we have to use a LIN, CAN, flex tray, and one more is the MOS. I missed it that because MOS is mostly used for most we can think about that actually media operated system, something like that. Okay, MOS is that we can see media oriented system transport. Okay, wherever the media oriented system transport is required, so this is the MOS is there. And Ethernet I have explained in the last. Right now Ethernet is happening. Ethernet is taking the very faster approach to replace this CAN, because CAN we can see. Okay, first I will explain about the network thing. Okay, how the network communication, what all different network is there. So different network we can think about the ring topology is there. we can think about the point-to-point communications. I can think. Then the bus type of the cluster, we can think about it. Okay. So in that case, the what all thing we can think about it. So lean, where we can use it. So lean, we can use that the single master. There will be single master will be there, and that single master and their multiple nodes will be connected, and it is used for a low-level communication system. Okay, and to access the bus, it is using the polling. Bus is nothing. It is you can think about here. Here is actually trunk switches, electric window, and it is the LIN. Once I am showing it here, it is actually bus. And what all are different data bytes per second? So it is showing that this is the data bytes per second has been used. And bandwidth wise, we can see that okay, what all bandwidth this is using. So, and physical layer, that what all physical layer it has been used. So any question in vehicle communications? Okay. So you are getting it or not? Actually, I knew that by reading these all things. Okay. This I got. This I never got a chance to work on mostly. Mostly I worked on the TCU part. Okay. And that I have explored it more, and then I've put it my thought here. So if anything was wrong, please let me know also that if someone is knowing it. Now we will come to the telematic control unit. Okay, telematic control unit. See, we have explained about the ECU navigation. So ECU, once you see the navigation system or any system or anything, so any vehicles having the lots of ECU, we can think about it. But in that case, how the telematic, what is the telematic control unit comes? So telematic control unit is also, we can think about it. The telematic control unit is also a ECU, but this ECU having the chip. Chip means this ECU having the SIM. That SIM having provided by the mobile operator. Suppose we want to access that the system. Suppose we want right now we want to connect the network. We want to access the laptop. Okay, if laptop would not have that some IP address, we cannot connect to you people. Similarly, if TCU will not have some IP address is defined, so it cannot be connected by the some of the network. Network means that outside of the network. So that TCU having one special part of this TCU having the SIM, and that SIM is provided by the mobile network operator. So once that electronic control unit is coming, that electronic control unit, and this is the line is there. This is the CAN bus. We can think about it. This is CAN bus, and this ECU is also there. That ECU is also connected through this CAN bus. So any message is coming on this CAN bus. So that TCU listens that okay, what we have to process it, and yes, on the basis of the processing of data, that listen it, and then it will send the signal to the mobile or cloud. Anywhere it will send the signals. Now the question comes that what all types of signals it can send, and how this mapping is happening. See, at the beginning I told that the ECU, that the software, yes, on the chip of the ECU the software is written. That software and this ECU, once it listen the signals, it is actually machine code. That machine code is converting by this TCU, by so what is happening at the inside the TCU, one controller will be there. That controller will convert the machine code to the whatever human can read. And suppose that the human can read about the REST API. So inside a telematic control unit, the software will listen this machine code, and it will convert into the REST controller, and it will send the REST controller to the wherever it has to send the data. That way it works. The TCU works, and that TCU is the gateway between the within the vehicle and the outside of the vehicle. So suppose that you want to control the car, you want to close the car from your mobile. So in that case, you will send the messages from your mobile. That you will send the REST API call from mobile to server. That server will say that okay, where we have to send the information. So that server having the record, having that okay, this car is mapped to the whatever, this car is mapped to what IP address. That's that IP address. And see, actually every car having the vehicle VIN, that's the vehicle identification number will be there. That vehicle identification number, it will send the signal that okay, this is the car, we need to send the signal to this car. So it REST API call will come to this TCU, and controller which is running inside inside a vehicle, it will convert the REST API call to the machine code, and that machine code will send the signals to okay, we have to close the gate of the car, or what all status of the car. That TCU can send the data on the cloud server, and from there we can see that the data, we can see that the different types of the different status of the vehicles on the mobile or wherever you want to see it. That way it works. So TCU having the multiple use cases there, the fleet management control is there. That I will explain in the next page. So any question here, the telematic control unit?
Madhup, I have a general question.
Yeah.
You have so many parts in the autonomous vehicle. In case hardware failures happen in some of the systems, so will the vehicle in that case not work properly, and it may result in accidents?
Right. Hello?
Yeah. So how is that prevented? How the safety is ensured in case of any hardware failures or malfunctioning of some components? What will happen in that case?
Okay. So suppose that the malfunctioning is happening. So one way is that okay. Now I'm explaining here what is happening here. Suppose that any malfunction is happening inside the ECU, there are the preventive measurement should be taken by the TCU. So one thing is that the TCU, what it will do that it will send a signal to nearby dealer. Okay, these all problems is coming in the car. Okay, so there is one more use case is coming. That there is a threshold. There will be a threshold malfunction. What is so everywhere this sensor will define that what is the threshold malware is going to happen. So before happening any malfunctions inside the ECU, it will send a signal to TCU, and that TCU will send a signal to the nearest by the authorized dealer, and that authorized dealer will call you to your place that okay, this is the service center. That service center you can come and you can fix it. And the second approach is that you should have the navigation system enabled. So through the navigation system, you will know that okay, which all service system, which all service dealer is nearby, so that you can find that okay, this is the nearby um, service center, so we should reach it. So that threshold should not break it. If threshold is breaking it, this autonomous vehicles means, and you are not taking care of it, this threshold value. So in that case, that the disaster can happen.
Like disaster in the sense, it may it may cause accident, or
It may see, yeah, it that that I'm
or
not
it
sure
may
that how.
overfunction. It may overfunction, or
Um, that I can say that if they are not following a disaster, so they are that system should be defined that if they are not following it, they have to just send a signal to just stop the car. That can be happen. One thing that is a preventive measurement by the OEM should take in it, or if they are not taking it, so in that case that some accident also can happen that if they are not putting this disaster system in yes into check,
yeah, yeah, okay, clear,
right?
yeah,
So that ECU part has to be taken care. Suppose if you are writing the code if you are not writing the try and catch plot and something going wrong, so what will happen you have to handle exceptions, correct? If you are not handling exception that something your code can break.
yes, yes.
Yeah, yeah, and someone has asked that in the earlier part, okay, what will be the voice part so in that case if we are giving the signal through the voice, what will happen? Okay, so there should be the voice recognition system in our applications. Okay, that voice recognition system uh, should recognize the voice by, and then then on the basis of the voice, or yes, on the basis of the command, that command should be executed by the ECU part. Okay, that is the whatever software is defined, that software will listen the voice, and then it will convert into the machine code, and that machine code will execute that okay, this function we have to do it.
Okay, Madhu.
No, any other questions? Yeah. Okay. Now we have to see the TCU use cases. So TCU use cases can be used at the electronic toll. We can use it. Second is that e-call. E-call, I explain you that okay, in that case how the roadside assistance service should happen, and then the second point is coming to the automatic crash notification. If something crash is happening at the okay, so in that case how the government authorities will should be indicated that okay, this is which part of the area some crash has happened and how to monitor this thing. So in that case they can track it who was driving the vehicle, or see actually who was the owner of the vehicle, and through that they can track it that okay, this is where the crash has happened. Vehicle tracking use case. Suppose car is going into the different route. Okay, so yeah, and we have the navigation system is enabled, and navigation system, through the navigation system, it can find that which area it has gone, or it has to it yes, it has been passed through it. So through that vehicle tracking we can find it. Remote door services, we can what we can do that we can okay. So yes, I have given you the yes, I have explained you regarding the one use case is that so vehicle will send the information about uh, yes about the status of the vehicles to the cloud, and suppose that they want to suppose the user wants to see the information about the car or about the vehicles. So in that case they should have the mobile or desktop information should be there. To that, if they are saying that the information that okay, I need my car vehicles, my door is not closed or door is open. So what he can see that he just saying that the one rest command, there is a different authentication mechanism is there. That authentication mechanism that it will saying that the to passing that the authentication mechanism, they will send the information to the car that okay, now the gate should be closed. That mechanism they can send it. One is a fleet management. Fleet management, fleet management we can say that suppose that the one driver one owner is there, and one owner having that lots of vehicle. So lots of vehicle, and to that TCU, if they will install a TCU into the car. So through the telematic control unit, they can know the status of their different driver, which all driver, where he is driving the car, and what is the speed of the car. There are different parameters they can measure it. Okay, so in that case that they can manage their whole fleet. Now that the video and the audio entertainment, this is suppose this is a new use case is coming, that video and audio entertainment. This video and audio entertainment, or we can say that okay, video and audio advertisement we can play to the car. Suppose that you have the connectivity with the OEM, and you want to play the sound advertisement on the some vehicle. So in that case they can directly they can have the connectivity with the OEM, and they can say that okay, this OEM vehicle can play this advertisement in between, like that if you are seeing the TV, and inside the TV the lots of advertisement is coming on the yes, on the OTT. That way that advertisement can be played. Diagnostic problem I explain you that okay, so in that case that if some issue is coming, something is reaching to the threshold value, that threshold value can be detected, and it can be sent to the nearest service dealer, and that service dealer can connect with the driver or the owner, and they can tell that okay, this all issues, or they can say get the notification on their mobile or any system. They can get it, and they can find that okay, this all issues are coming, and so how can we diagnose it. Diagnostic system also can be used by the service dealer. So in that case, the service dealer, what they will do that they are knowing that okay, this all issue having the issues. So if they can connect that, if they will make that some diagnostic system, so they will find that okay, this what all issues and which all issues are coming from which ECU. So that way they can find it, and they can fix it very fast. Second, and one more use case I am seeing that this is an insurance policy use case. So they can so we know that okay, what is the status of the car. We know that what is what all condition the car is running. What is the, and we can find that okay, so car has run perfectly, run smoothly, or some crash has happened or not, or car, if someone is driving it, so what is the so in that case how much they have put the brake, what all efficiently they are making running the car. That use case can be solved by the insurance policy people, and that insurance people will tell that okay, this much insurance, yes, on the basis of the algorithm which is available for that vehicle data, that can be fine, and that that insurance can be enabled by the vehicle for the vehicle. So anything here? No questions? Okay. So, okay. Now one use case is we can solve it not sending your data onto the TCU, but we can send a report on the TCU through the TCU on the cloud. This is for the ADAS system, and once you are seeing here a chip, the chip you are seeing that actually it is an ECU. So here, what can we find at the in that case how much speed the car is driving, and then what is the distance between the two car by sensing that this is all distance, and then what is the brake the driver needed, that can be computed inside the car itself. But you can tell that so it is a small controller. How can be the small controller can solve this car? But we have we have actually high performance system should be implemented inside a car, so that it can verify, it can compute all this thing, and it can let us know that the driver, these all issue will come, and they can fix and they can let the driver to know, this is the way, this is the speed, this is the brake, they have to implement it. And yes, on the dashboard he can verify that this is the brake pedal he has implemented or not, and it is a safety driving speed or not. That way they can do it. Okay. So any questions here?
So Madhu, what are the technologies, tech stack, which is used for autonomous vehicle?
We can use whatever microservice implementations we are using, like the Java Spring Boot, Java Spring Boot, and database side we can use any relational database, or we can use the NoSQL database. We can use it, and that we can write it inside of the controller defined in the ECU. Okay.
And for doing the computation in between the two vehicles, exactly like how much distance is there, and exactly when we have to put the brake. So like how that thing will happen, how that calculation will happen inside, in what system it will happen, that particular calculation.
Right. This is the vehicle speed, you are knowing it, correct? Vehicle speed is this one. Yes. You are knowing that the distance yes. means that from one so from the sensor it will know from the part, so what is the distance between the vehicles, correct? So
yes.
Yes, I am just giving you the example, and then after getting the vehicle speed and the distance between the speed, they will know that this is so so it will measure it multiple data points for distance and the speed. Suppose the distance is decreasing between the car and the speed is increasing, so in that case the high probability of there is actually high probability of accident between the two cars.
Yes,
if distance is increasing. So that way they are doing the computations, and it will tell that the ECU, it will so in that case the ECU component will be there. That ECU component will So you do on the dashboard, okay, this is the you have to put the brake on the vehicle. If driver is not there, if actually autonomous vehicle is there, so in that case, what will it will do that? ECU will send the communication. ECU will send the communication onto the brake ECU, okay, and that brake
Okay.
ECU will send that brake ECU will put that um, put the brake, and while doing the brake, that brake pedal will connect it with the uh, vehicle vehicle wheel, front wheel, and the back wheel, and then a light back side. So it will connect it to the network. That network I told about, the safety network is there. That that will be defined. That safety network will get enabled, and then it will put the brake, and that will happen.
Okay. Okay. I got it. Got it. Thank you.
And one more question is there coming here. See, if you want to get the data, now you want to get the data that, okay, there are lots of things about the vehicles, you told it. Now I want to experiment in that. How can I experiment it? Okay. So here, see, now whatever car system is there, you will get that everywhere that the ECU, you will find that okay, actually automotive vehicle, you will find the ECU is there. ECU is got enabled. Now you have to get the data from the ECU. Okay, so there are multiple port is there on the ECU part. This is you can see that the long port is there. That long port you have to connect by the odometer. Odometer is you can find it from the market. You don't have to get it. And once you connect this odometer, that odometer, this is the one tool. That tool will tell you that all the data, but that tool will give you the machine code. That machine code you have to learn it. And then you can do that that machine code. Once you are converting into your application code, that you will get a lots of information about the data in the car. Okay.
Uh, and that machine code is written in which language? Machine code?
Binary code. This machine
Okay.
code is binary code.
Okay, binary code.
Yeah.
Madhu, I have a question. It's like how it will consider weather condition, because weather is one thing and road condition one thing. Road can be wet or slippery. Okay, even though, for example, if some places it will be rainy, some places it won't be rainy, but roads will be slippery. Or these consideration will be taken care, and how it will how it will sense the data.
Okay. So there will be some sensor will be there on the body parts of the car. Okay, and this body part of the car, you will find it, okay, some sensor. Okay, that sensor will, and once raining is there, so that time there's some humidity difference will be there, or some, if sunny season will be there, some humidity difference will be there, correct? So in that case that sensor will indicate that okay, right now it is raining season, or water level somewhere it is getting increased, or water is getting locked there on the wiper side. Okay, so they will know that okay, this is water is getting locked on the system or on the wiper. So in that case that they will know that okay, now it is raining. Okay, water can be locked by the different way also, but through the humidity they can find it, and they can send a signal to the ECU, to the network. Okay, and that network will know that okay, this is the and that network will communicate to the TCU part, and TCU will send the signals to the cloud. Okay, or any data center it will send you, and through that the vehicle which is running behind it, they will know that okay, or whoever is passing in that way, they will know about that okay, this is what all conditions is what all navigation system is also enabled. So that navigation system, they will find out whether it is raining or it is a sunny season.
Okay, but road condition can be different, right, compared to weather. Even though weather
Yeah.
is dry, there can be roads can be wet.
Yeah.
In that
Roads.
case, yeah.
Yeah. So road conditions, we can think about it. Okay, road condition. If we are thinking about a braking system, suppose the road is getting slippery. Okay. Now, first I'm explaining about a braking system. Then I will come about the road system. That how can we sense about a road system? Okay. So suppose that at a time rainy season is there, and rainy season, and there is a slippery, there is a getting chance of the slippery. Okay. So, so here you have seen in the car that the ABS has been implemented. So actually, what does the ABS does then? It works on a multiple principle. One is the threshold braking, and second is the uh, cadesive braking. So this is the main component of the main component. Uh, Main component. What does it do? Rather, it is actually verifying the speed sensor. Then it will verify the valves. Then it is verify the pump. Then the controller, and the see actually on the basis of this thresholds and the um, cadence braking system. So it actually enables the car. It enables the ECU that okay, this is the maximum braking can be enabled. This is the one use cases we can do it. Now the road condition can be got by the camera. Okay, what is the road condition of the road condition? That can be, we have to put that everywhere the camera will let you know that okay, what all condition of the road at that particular navigation point.
Okay, got it.
Okay.
So Madhu, one question: what all computation happens within the car, and what all computation happens in the cloud?
Okay. Uh, okay. See, cloud, once we can say that the cloud computations, so what all use cases we want to implement on the TCU related activities, that computations we can do on the cloud. Okay. But if vehicle related data, we want an instant, we want an instant application on the vehicles. So that type of informations can be computed inside a car. Suppose that I told about the regarding the ABS, okay, or braking. We told about the braking. Now the crashing. If suppose the crash is just to happen, or suppose the puncture is getting happen. So in that case, the what you have to do the enable in the vehicles, that will be computed inside the vehicle itself. But but that data, if we want to store that data, we can store onto the cloud by sending to the TCU. But if you want the multiple use cases like uh, like the insurance, yes, insurance thing, okay, and navigation system, radar system, yes, that way that we can say that or toll tracking, okay, that all information or service dealer, that all computations we can do it on the cloud itself.
Okay.
Okay.
Now,
Yeah.
next
Any other?
question. I have one more question.
Yeah.
So there are so many communication involves within various units. For example, communication of the video data, and then you talked about REST-based communications in microservices. What all protocols are used?
Okay. Uh, okay. Protocols wise, yeah. That network side I told about that. Okay, this network communication is happening. Protocol level, I have not gone through that. Okay, which all protocols is happening, that I have not gone through it. Okay, I'm not sure about it basically.
Okay.
I think this one I need to explain it. Okay. So here actually advanced driver system. I have explained about the TCU part of the how the TCU is working. So in that case, what is happening at the we are sending this vehicle data on the cloud. Okay, and we are knowing that okay, what is the we are knowing that the how the status of the road. Okay, and what is the and in that case we are also knowing that okay, what is the width of the car, and in that case we are knowing from the sensing that the okay, what all railing has been implemented beside the car. Okay, so what is the width of the road basically? We know that okay, where so and through that we will know that okay, this car is going this route, and for that particular navigation we will know that the what is the status of the road. So that way it will actually help the other driver which is coming behind, if it is a autonomous vehicle. So in that case it will pass the information, but that autonomous vehicle, um, suppose that okay, suppose we are running the car in India, and someone has put that as something instantly, um, something blocker they have put it. So that type of use cases we cannot implement in India, but on the yes, on the other country this use case has been enabled. Similarly, here I have shown to the mobile. So we can get all the information about the vehicles on through the mobile or any desktop system. We can get it. So wherever you want to get the information about the car vehicles, that you can connect it to the cloud, and that you can get the data. But one question will come that okay, if network will not be there, so what will happen then? If network will not be there, so it is very difficult to get a data, real time of data. Basically, in my company, I'm working on the fleet management right now. Previously, I worked on this TCU part. I worked it, and fleet management. We are knowing that okay, how can we manage the fleet with the different owner of the car. Okay, and yeah. Anyone wants to ask a question?
Like as a electronics engineer you have worked, or like both software role and electronics role both?
No. I work only on the software role. I never got a chance to work on the electronic side.
So only the software role?
Yeah, software role.
Okay.
Services part, I got a chance to work, and how the services working, that I know.
Thank you.
Yeah, one use case is the driver behavior. Okay, that I just copied it somewhere. So in that case, how they are putting so in that case, how they are going smoothly, and this is the red color. You can see that the red color how so it is a more darker red color. More darker means they are putting the brake continuously. So in that case, that fleet owner will know that okay, how the driving behavior of the driver, okay, and why it is taking lots of time. Okay, that way you can measure it. Okay. And if you tell me that the one video I having that how this mechanical behavior works, that I will play that the video. Okay. So, okay, may I play the video?
Yes.
So it is coming. Sound is coming. Yeah. Uh, this video is regarding the uh, this video is regarding the ECM. Actually, what does mean the ECM? I forgot the full name. Okay, this is for the engine management control, engine control module. So in that case, how the engine control module is working. So once you see that the input device is actually sensor, and once you see the output device is is the actuator, and the ECM is ECM. We can think about that this one ECU. Yeah. So any questions? So you are feeling boring? Sorry if whatever I'm knowing that I have just explained you that if you want to learn more that I can give that some of the sites name that you can go and learn it. That I can tell. But right now I do not have the site information set.
It is very interesting actually. Like this role doesn't look like a software engineer role. It looks like a more like electronics, the systems. Is that a software engineer role? Just like
Yeah, and that's why see. Actually, I have
like
explained about the yes, I have explained about the autonomous vehicles. But
yes.
software comes that okay, once we are writing the services that services we have to like the fleet manager. I told about the fleet management. That fleet management we can write a services, and once we writing a TCU, that is a telematic control unit. We can we can we can we can write a software there, and that software can be used to communicate between the ECU as well as the cloud. So that way that the software comes.
Okay. Okay. To write the software in TCU, like what are the languages? In which language you will be writing?
Yeah, we are using the Java Spring Boot,
Okay.
and we are using that this MongoDB. We are using it, and to communicate to the ECU that we have to connect with the with our device team. That device team will let us know that okay, this all communication we need to send it. That communication it will translate by the device team.
Okay. 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 I got it.
That I explained to the autonomous vehicle. I am not okay. If you wanted more information about it, how it is written for the services part, that services part, whatever we are writing the REST API call, that REST API call will work on the services part also.
Okay.
Regarding technology, there is no barrier there.
Yeah. Yeah. Okay. Got it. Got it.
Yeah, any other questions?
ECUs, they are Linux based systems, or what kind of operating system they have?
ECU is the Linux based system.
Linux, okay.
Yeah.
And any problems you have faced during working, like any?
Yeah, there will be lots of problem will come that once you are connecting with a device team, then we'll have to face lots like that. Okay, sometime the latencies will come that we are sending the signals but they are not getting the signals. Okay, so in that case that we have to see that okay how this thing can be solved. Second thing is that whatever they are expecting that we are sending in the correct format, but they are not able to reach it. So we have to use. Okay, I forgot it. Yes, Tarun has asked about it. Okay, which protocol communication we are using it? We are using the MQTT protocol here, and the MQTT protocols, and then what will happen that sometimes that we have to trade off the MQTT AMQP protocol and the XAMPP protocol that we have to trade off, and that way we have to send the signals to the ECU.
Okay. Like particularly any particular problem you have faced and you have solved that, which is very interesting that you want to share. Like anything is there like that?
In the next class, I will explain you that okay, what type of problem I will say. So by practical way, I can yes, I explain you.
Okay, okay, fine. Okay, thank you.
Yeah. So any other questions here? No questions?
Yeah, I think
Okay.
everyone's done.
Okay. Tell me one thing that you people are feeling boring or what? I just want to get the feedback.
No, it is very much interesting to see all those technologies at one place and you are able to explain everything so fluently. It is really great to see all that. Like about the autonomous vehicle and the way the systems are working and all those things when you are explaining. No, it was really good to hear all that. It's very interesting actually. Yeah. We'll not be able to find this kind of class anywhere. I don't think so. Yeah.
You can get a practicality also from your car that if you have some automatic vehicle is there, that car that you can go and you can connect with see actually whoever the Hyundai or Maruti is there, that dealer you can tell that okay I need to connect that one software one hardware is there actually odometer yeah. Odometer will just listen from the report and you will get all the data.
Okay. Okay, I'll try that.
Yeah. And even that ECU in coming days it will replace by the HPC. That is actually the high performance computing because there are lots of data will generate inside a car itself in one day, in single day. So that HPC, I do not have the more idea that how the HPC works. That it is actually they are segregated as a cluster and a node is processing this data, and there are different types of the HPC. Yeah. So any other questions? No questions? Okay.
Great, Madhu. So was very nice presentation, and your presentation slides were also very informative, and you have covered a lot of topics. So I think everyone learned a lot in this session, and then definitely looking forward for next sessions. Yeah, more advanced topics you can kind of cover going forward.
Sure. This is a theoretical thing. That's why I covered this all things that we should know all this ECO, TCO, and this thing. So in that case, how the communication is happening between the car component and the car to cloud. That's why we should know that. Then we should know that okay, how from the ECU to TCU how communication will happen. That if I will find it as some simulator, I will write it as some code so that I will explain to you people that okay, everybody will know that okay how this communication is happening, so that you can do this or practicality in yes at your home. And nowadays this autonomous vehicle is getting boomed. So if you are doing that as something want to learn it, so you can learn it from your own side, and then you can do some write the application, and that application can be useful for some other use cases. That what all use cases I explained. That apart from this use cases, also there are many use cases we can solve it, and we can give that some we can create some startup also here.
Great. Yeah, so maybe that would be very interesting to play around with some simulators and see something working and trying out, maybe some algorithms on various modules of this autonomous vehicle.
Right.
Great.
Yeah. So can we close the call?
Yes, yes,
Any
sure,
information anyone
definitely.
wants?
Definitely, no, we can close the call. And thanks to you again. And thanks for all the participants also to interact in this session and also share various points. So this was useful. Great. See you then all in the next
See you.
session. Okay, bye.
See you. Thank you.
Thank you, Madhu.
Bye-bye.
Thank you, Tarun.
Thanks all. Bye.
Madhu, thank you.
Thank you.
Thank you very much.
Thank you all. Bye.
I'm saying you are in the beach.
Yeah. Yeah, on the beach. Enjoying the beach today.
Okay. Great.
Yeah.
So nice to have the presentation from the beach.
Yeah. So, can we go ahead, or else I have to wait for some time?
Okay, I will just start the recording in a minute, and I'll just remind everyone over WhatsApp. Then we can start. Just give me 2 minutes.
Sure, Tarun.